Hello, this is Spencer Scott, and I'd like to show you a demonstration of the project I've been working on this term. My project combined embedded systems and fuzzy systems, and my project was an aquaponics system, which is basically a habitat where fish and plants coexist in an ecosystem where the fish waste actually feeds the plants. So over here I have the start of what it is, the aquarium. This is the part that requires the most monitoring. And so some of the values that we're monitoring here are, we have a pH probe. So this is like the pH circuitry, and here is the supporting probe. We have air temperature, lumens, and then we also have water temperature here. So all these sensors are hooked up to an Arduino, pretty common microcontroller board, pretty easy to get up and running. Just some of the difficulties are involved with, hardware can be tricky, and a lot of these devices require special drivers to run. They're not all uniform, so that took some time to really work through some of those issues, but everything's up and running now, and so the values will update to the server. So over here we can see the values on the server, and you got your water temperature, pH, air temperature, and flux level, and you can see that just updated to the latest values there. Another cool feature is if anything is out of range, for example the pH, I will get a Twitter message saying that my aquaponics system is either turning on the lights or the pH is out of range and not stable, and so that way I can go and monitor it. Future improvements could be creating something that would automatically fix the pH, but that's something that's kind of tricky because you have to physically add chemicals to help balance. So we'll move on to showing you the fuzzy logic system. So let's see here. This is done in MATLAB, and I did all my programming in MATLAB as well. So that was an interesting task, and learned a lot about the interface between Arduino and MATLAB and how powerful they can be. So here we'll start with there's water temperature, pH, air temperature, and lumens as the inputs, and obviously they control the heater, alarm, and light. So those are our outputs. Over here are our rules. So we have some 9 sets of rules. The temperatures are combined and the other ones are separate, and just simple things like if pH is high, turn the alarm on. If we come up here, we can see a visual representation of the rules. So for example, if our water temperature is low, our air temperature is low, our pH is low, then set the alarm and turn the heater on. So basically what we're saying, the way I evaluated these was anything above 0.5 perform an action, such as in this case on, and then below 0.5 I would turn the heater off or the alarm off or the light off. So the light's right in the center, but if it were to shift, then we would get different values there. So you can see how that fuzzy system works, and I will bring up this one more time. So this is the MATLAB project that updates the variables simultaneously. Every 25 seconds it samples based off these timer functions. So that's really all I had to demonstrate. Thank you for watching, and hopefully you enjoyed my demonstration.